Hello everybody, today I'm going to explain the second problem of the USACO 2024 December contest from the Bronze Division, the problem Farmer John's cheese block. If you haven't watched the video I made for the first problem, I attached the link in the description and I recommend you to watch that video as well. In this problem we are given a block of cheese in the shape of a cube, and this cube is quite big, has 1000 cube squares. And basically, during each day, the farmer will carve out the one by one block of cheese extending from the coordinates x, y, z to x plus 1, y plus 1, z plus 1. And given that we have these additions, we need to be able to find out at the end of each day how many blocks of brick we can actually place, how many ways we can actually stick one by n brick in such a way that the given brick doesn't overlap with any of the cheese remaining. And we are given the size of the cube, the number of queries, and after each query we need to update the answer. First off, the grid is quite big, so I would say that the most important thing to know is that we can't just do a brute force and check for every day, every way to place the brick and see if there is no cheese there left. Knowing this, we actually need to find some conditions which allow us to be able to figure out whether we can actually place the given brick. And now, something which has to be observed is that when it comes to these updates, we want to be able to find a way to quickly see whether there is an entire plane or an entire side of the cube for which we actually took out every single cheese block. Because if you take out every single cheese block, then you can place the one by one n brick without any problem. And if we look at the third day, we will see that the answer is 1. And the reason the answer is 1 is because we have the first and the third update, which removed the cheese blocks from the 00xz plane. And because of these two, now we know that everything here is taken away. They guarantee us that we don't have duplicates, so we don't have to check that additional case. And after the fourth day, we will observe the same thing happened with the YZ00, where both of these were removed. And at the end of the fifth day, we will have several new placements for the brick. And it's very important to notice that once we can place a brick in a certain plane, we will be able to place it for the rest of our process. And with that being said, I kept mentioning during this explanation so far the fact that we only care about the separate planes, and the XY plane, the XZ plane, and the YZ plane. And because we know that bricks can only be taken out, the cheese cubes can only be taken out, all we have to do is to actually check whether for each of these blocks, adding it will make an entire row on either of the planes be full of cheese blocks that were taken out. And this is actually something that can be done relatively fast by just storing some 2D arrays, where for each array we store how many of the cheese blocks were taken out. And you can do that for each of the 3 planes. And whenever you add one of these coordinates, whenever you take one of these bricks, all you have to check is whether the number of blocks you took out is equal to n. And this is actually something that can be coded in a very small number of lines, and it's actually quite easy to see. So I have these 3 2D grids, X, Y, X, Z, and Y, Z for each of the three types of planes. And I use these coordinates to increment the number of cheese blocks taken out. I do it for XY, XZ, and YZ. And if for each of these we have a new brick, a new complete layer taken out, we increment the answer. And actually this is the entire code. So you can see that for this problem, finding the idea and the observation that we can actually optimize the process of checking for each plane whether having that new brick will be decisive in terms of having the complete row or column taken. Then it's just about finding out whether they are all adding up to n. And as far as some slower solutions go, if you didn't find this idea, you can always think at the fact that when you place a new square, when you take it from the grid, only the sides that include that square will be affected. So you can even check whether for all of these sides every brick has been taken out and you can place it or not. But again, because we are guaranteed that the updates do not affect the same position twice, it's enough to just check whether the count from that square is equal to n. And this problem is actually, I would say, while the implementation was by far the easiest, it was also the problem where it could be a bit harder to find the idea without observing how the process really works. So it's important to have in mind that for problems like this, it's often good to think at simple approaches that don't require some heavy work. And with that being said, thanks for having watched this video. I hope you enjoyed it. If you or your friends are interested in learning more about USACO or taking the future contests, I hope you show them these videos on my channel, and I hope you subscribe to the channel and obviously like and share the video. And if you or someone you know is interested in working more closely with me and having my experience guide them towards the higher levels of USACO, you can check out my website in the description for ways to interact more closely with me. Until the next time, happy holidays. Please watch the other videos I made for Bronze Division, and also, as usual, yeah, thanks for joining the video, thanks for watching it, happy holidays, and good luck with the rest of the USACO contests. Stay tuned. See you.